Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
Hi there, and welcome to Industrial Talk, the number one industrial-related podcast in the universe that celebrates you, industry professionals all around the world. I say it all the time, you're bold, brave, you dare greatly, you innovate, you collaborate. You are making the world a better place. That's why we celebrate you on this platform. We've got a great conversation. Siemens Energy is in the house. We have Matt and Sergey, and we're going to be talking a little bit about the challenges that are taking place and the solutions that can be applied specifically to our grid. They have the solutions. They have the insights. It's fantastic. A must. It's a paper and pencil conversation. All right. Let's get cracking with the conversation. If there's a conversation that I always like to have, it's anything that deals with power generation, utilities, grid, the challenges that are happening out there, and being able to talk to leaders such as Matt and Sergey. It's such a joy. I can't express the amount of energy that exists out in industry. This whole industrial renaissance, which I have an ebook out on Industrial Talk. Just go out to Industrial Talk, get it. It's free. But the amount of energy that exists, the speed, if you're not committed to that whole education and collaboration and innovation, you're going to be left behind. I can't keep up with it. I feel like I'm holding a tiger by the tail and trying to keep up with all of the incredible innovation and solutions. And again, at the core of all of these conversations is the ability to collaborate. You need to collaborate. You don't have all the answers. I hate to break it to you like that, but you don't. And it's important that you have the answers or collaborate with the individuals that could truly help you. It's an amazing thing. It's amazing. Anyway, a couple of things of importance. One, again, I mentioned the ebook. It's out on Industrial Talk. It takes you through all of the conversations. Well, I can't say all because I've had 3,000 of these conversations, but it takes you through some of the core components associated with what make industrial companies successful. And I mentioned three of them. That's, of course, education, collaboration, and innovation. But they create a great culture. They create a great culture that is supportive of all of this stuff. I urge you to get it out on Industrial Talk. It's just right there. Second thing is that we're starting a news network, an industrial news network. And it is taking an industry that is ripe for information and centralizing it into one area so that you can get the information that you need. It's delivering on the necessity to make it entertaining and informative. We're up in our game. That's the Industrial News Network that go out to. It's just a landing page right now, but we're getting a good cadre of individuals and companies to participate in this. We want you to as well. On to the conversation. Siemens Energy, Matt and Sergey, talking about their solutions, about how to truly, especially when it comes to these data centers, way above my pay grade. Not above their pay grade because they deliver. They know exactly what they're doing. All right, here's the conversation. Matt and Sergey, welcome to Industrial Talk. Thank you very much for finding time in your busy schedule to talk to the best listener base in all of industry. How you guys doing today?
Doing good.
Did you guys have a good weekend?
Well, I had a long week. I was on vacation for the whole week of the 4th, so I'm a little rusty this morning.
Where'd you go?
This got my wheels turning.
Where'd you go?
Just to the North Carolina beach. Where else?
Yeah, where else? Hey, didn't you guys get storm? Wasn't there a storm coming in?
Little bit of rain. That was about it.
Oh, it was all hype. Oh, man. I thought Armageddon was going to hit the coast. No, apparently not. All right. For the listeners out there, let's level set. Let's do a little background on who Matt and Sergey is. Matt, give us a background on who you are.
Yeah, I am Matt Neal. I work for Siemens Energy, live in Raleigh, North Carolina, and I'm responsible for our North America business for grid solutions. And that is a business that we build substations, we stabilize the grid with our fax devices, and we build HVDC projects for large bulk power transfer. So it keeps us busy.
You threw out a sort of a quick little acronym. What did you say? Sort of.
So I'll start. So fax devices, FACTS, flexible AC transmission systems.
There you go.
And then HVDC, high voltage direct current. So where we we transfer power long distances with DC power, and we do that with our converter stations. So
see, there you go. Be careful of those acronyms. I will stub my toe in a big way on those things, and I'll call you out. Sergey, give us a little background on who you are.
Yeah, my name is Sergey Kynev. I'm working in the same office as Matt, and I spent my entire career with Siemens Energy now, 14 years. Just started after I graduated, and I spent it all in a group which design and manufacture grid stability equipment. I started in our headquarters in Germany, and 7 years ago I moved to Raleigh, North Carolina, just to be focused on U.S. market, and always been doing engineering for grid stability equipment like a STATCOM or E-STATCOM, which we might touch on today.
Very cool. I have to ask, Sergey, this grid stability, which we will be talking about probably the majority of the conversation. Now, it's tough not to talk to you, Matt, about what you guys, trust me, I'm pulling the reins a little bit, but when we start talking about grid stability, we talk about transmission, we talk about the power generation side, that makes sense. Does your solutions also address stability down to the distribution level?
It's kind of, we focus on transmission, and if transmission, and there is no stability in transmission, there is no stability in distribution, right? But our market is mostly focusing on a large devices, which would mostly apply to transmission. There are some cases where we would also do distribution, but we focus on kind of large tailor-made projects, which would target a high voltage.
I'm going to digress a little bit, but we will get into SATCOM, E-STATCOM. We will be talking about that. But Matt, when I was a lineman many years ago, you know what conversations we were having? We need more transmission lines. We need more capacity. And you know what we're talking about today? We need more transmission lines. We need more capacity. Are we making the existing transmission system more efficient so that we can use what infrastructure we have, or are we actually building transmission assets?
Yeah, I mean, if you just looked to the last 10 years, and I've been in transmission about 10 years, and originally, I mean, we've been growing in that entire time, right? Now I would say we're in like hyper growth as far as building transmission assets. But a lot of it was at the, and again, about a decade ago, we really started to see the penetration of renewables require us to do so much more build out of the grid. And then now we are doubling down or having to, like I said, this hyper growth we're in with the load changing, and the load from data center load. I mean, if I just speak about the US, from reshoring manufacturing, just population growth and consumption of power. So I think it's a question that those of us in the industry all want to answer yes to, because we're so focused on reliability. But I think there's definitely I don't want to say the word fear, but a general concern in the market that it's hard to keep up with everything that's going on.
Yeah, so. I get that same sense. I do, and you just can't flip a. I shall use this analogy. You can't just flip a switch and be able to say more transmission lines, more substations. Here we are. They take time. They take planning, and I struggle with balancing this rapid market evolution that's taking place and just the physical realities of, yes, we need to do that here, and thank goodness for companies like Siemens that do that. Now, Sergey, give us a little sort of background into STATCOM, E-STATCOM. Give us what that solution helps us with.
Yeah. So maybe let's start. What is the stability of the grid, right? And why we are concerned about it, right? It's all boils down to like a power system as a system is always like a balancing act on balancing two major parameters, which is frequency and voltage, right? And frequency is kind of easier to understand. This is a balance act between generation and the load, right? So we want to keep frequency stable, but we also want to keep voltage stable, right? So voltage cannot be too high and it cannot be too low, right? Because our equipment malfunction. So the way you control voltage is something what we call reactive power in a power system, right? And for someone who maybe not coming from a power system, reactive power is a bit of a weird concept, right? It's not something you can use as a work. It's not something which will make your toaster works. It's something which is kind of think about it as a support system. So like if a fuel in your engine is an active power and reactive power is a grease, is a oil, right, to make it running, right? And this keeps the voltage. And there is only few devices in the grid which can provide reactive power and can control voltage. So STATCOM is one of them. And this is what STATCOM is all about. STATCOM stands for Static Synchronous Compensator. And this is a device which you add to your power grid and it automatically controls the voltage, right? by providing the reactive power.
Can I just dive in here real quick? Mm-hmm. With that product, that solution, where do you place it? I mean, it can't be. It has to be strategically placed in a area that makes sense.
Right. Yeah, ideally you will have a fleet of them connected to the key transmission substation, right? And don't think about like a device like a small box. It looks more like a substation, like it will have its own building. It's a pretty large. Like a medium-sized substation, if you think about it this way, right? And you're connected to the key transmission points, which would be sensitive to the voltage and to the reactive power. As often, you talk about like we're not building enough transmission line. Often the limit is not enough transmission line, but the limit there is so-called stability limit, right? We are not letting so much power to flow through this line because the voltage hits the limit, right? So adding a STATCOM, you can unlock some transmission capacity through your line by just adding this device without building more lines. So there are a lot of cases like this where you can unlock this potential.
See, what I see happening out in the market today, given the challenges and given all of the demands being placed on today's grid, Matt, it just seems to me that more focus is necessary on ensuring a stable grid so that consumers like me can not worry, whatever. We've been in countries where that doesn't exist and they take it for granted, but here we don't. And it would seem to me that the solutions that are being offered by Siemens Energy have to be quite nimble because it's changing so quickly. How how does Siemens Energy do that?
Yeah, I mean, I think the first thing is we work with a lot of partners. We even have our own capabilities to run studies so that we're constantly trying to look ahead and predict where these new load pockets are going to be, where new generation is coming online. And also just this technology that we're talking about here today, the STATCOMs that Sergey was mentioning, they're a lot more flexible than they were in the past. Like there were previous generations that of devices that offered similar services to the grid. And one of the big advantages now of these modern STATCOMs is that they are power electronics based, and then they have very sophisticated control systems that are controlling them, that allow them to also adapt as the grid changes. So there's a lot more flexibility in buying these assets that we offer to our customers than when we used to put kind of fixed capacitors or reactors on the grid.
Yeah.
I mean, that equipment has really long lead times. So if you had a change where you say, hey, this reactor's not big enough, or we need more capacitors over here, I mean, we can't wait 2 years, right, or 3 years for them to be delivered. But with these new power electronics based solutions, we can go into the control system and modify them to provide other services, or simply change how quickly they ramp up, how quickly they ramp down, those kind of things that allow the grid to kind of change as we go.
Is this solution, Sergey? I think of the system operator. I think of what their responsibility is, and how does the solution sort of interact with their obligation to just make sure supply matches demand, clean power, all of the stuff. When I say clean, I'm not talking about renewables. I'm just talking about power quality. So how does this solution work with the system operator?
Yeah, and this is a very important point, and a cool thing about STATCOM. It's kind of work autonomously, because there is so much control and so much brain to do its own decisions, right? So it's not only waiting for operator command to switch on or switch off like a capacitor bank would be, right? A typical classical example, like an operator sitting and seeing a voltage getting too high. Okay, let's send a command and trip this capacitor bank, right? With a STATCOM, he doesn't need to do all of this. STATCOM provide the whole range of power. It's not just zero and full. It can do anything in between, right? And it's fully automatic. It has its own control system. It looks at the voltage and has a command settings of controlling this voltage. So in a way, operator doesn't need to do anything. It does it automatically, and it does it very precisely and extremely quick, right? We're talking about milliseconds, right? Because in a power grid, a lot of stability, what we're talking about, if there is a long-term stabilities, but there is also this transient stability and like effects which are happening within milliseconds. And it's just too quick for any operator to react or do anything like this. So you need devices which would react almost instantaneously to the grid. And during design, we would run a lot of studies, a lot of contingencies. So we would model different events which might happen in the grid and demonstrate the capabilities of STATCOM.
It would seem to me that's very to the point. I appreciate that, sir, because I again, my thinking is sort of old school, and I remember going to the system operator back then, and they were just intently focused on making sure that power met demand and so on and so forth. It would seem to me, Matt, that as we continue to venture into this brave new world where we see greater demand on our transmission system, greater demand for power generation, that the electronics need to be more automated, per Sergey, so that we can have a more efficient and responsive grid. That's where we have to go, because as a system operator, I can't, it's just too much.
Yeah.
I need automation.
Yeah, and I mean, I think that's what we're talking about here, and it's also I think that flexibility is also needed because of how we do our system planning, right? I mean, there's a lot in the news about how we do long range planning or lack of long range planning, and how we're always kind of behind that the plans that we're using to build the assets of today are probably even outdated, right? So we really, as OEMs and technology providers, are having to kind of provide flexibility and like you said, automation in our solutions to deal with the complexity and the regulatory environment of kind of, system operators giving utilities the freedom to go buy the assets they need is sometimes not there. So they have to buy assets that are flexible.
You just knocked it out of the park on identifying the planning component as well as the regulatory environment. This is what dazzles me. Being a part of the utility business for many years, utilities as well as the regulators, they're not known, and I guarantee you, it has not been put into the same sentence. They're not known for being nimble. And this requires some sort of a nimble mindset to be able to recognize that things are happening fast. I've got to sort of respond with some sort of urgency to be able to sort of satisfy the demands of the market. Is that correct, Sergey?
Yeah, definitely. I mean, we are in a way a bit of a conservative industry, and for the right reasons, right? Yeah. We need to be in conservative industry because we rather be slow but reliable, right? Than go and break things. How in other industry it might happen, right? Because we don't want to break things, but it's just. The speed of a change what's happening now, right? Everyone been thinking the speed of renewable integration was crazy, but now look at the data center, right? The speed of they coming in is it's just fantastic. It's bigger than what you ever saw our industry saw, at least in this country.
Lay it. Talk to us about these data centers, because I heard a lot about them when I was at some of these conferences. The demand for power is going through the roof. The demand. I heard somebody talk about the need for generation, right, is going to increase 3 times coming in the future, whatever that time. 3 times greater demand for power as a result of these data centers. And we're not going, that genie's out of the bottle. How do we address that, Sergey?
Yeah, it's a very interesting time to be a power system engineer. Yes. Definitely. There is a lot of challenges coming with this. It's not just how large they are also large and concentrated in one place, right? So some of data center we see in a scale of a gigawatt or a 2 gigawatt, right? It's a scale of a city. Like what's happening if this data center is tripped or something happened, right? It's just a very huge impact to the power grid. And there is another aspect. And there is another aspect of this, what we see, and it's very kind of a new phenomena to the power grid, the way the load behave. Especially when you look at the AI data centers, right? They are very different from conventional data centers, what we know, which used for streaming and cloud services. AI data center, they're not there to save data. They are more to compute data, right?
Processing.
The processing, yes, they use GPUs, right? That's why the NVIDIA stocks are so high now, right? But for electrical engineers, this looks very interesting, right? It's look like the whole load is no longer steady. The load is peaking within milliseconds, sometimes seconds, and then peak back, depending on whatever the model you run on this particular AI data centers, whatever computational software you're running. So it's very unique behavior of the load, which we haven't seen before. Something we saw very similar to this was coming from an arc furnace, right? Arc furnace would do something similar where the load is not steady. you probably know this, but in a much smaller scale. And we've been deploying our solution STATCOM to smooth it out for many years. Right. What is unique for AI data centers? This is a real active power demand and peaks. And what we see a lot of interest is basically to take our solutions, the STATCOM, what we talk about, and enhance it with some form of storage, which would smooth out this load fluctuation and make it more friendly towards the grid. And what we are using, we are adding to the STATCOM, we are adding supercapacitors, and we call it E-STATCOM, so adding energy to the STATCOM to be able to provide not just reactive power, what we talked before, but also active power, and to smooth out the fluctuation coming from data center. So this is kind of a very new topic also to us, what we're working on right now.
Yeah, Matt, it's happening, whether we like it or not. It's these data centers. If you ever go to Reston, Virginia, that's a pretty cool place. There's a lot of data centers there, and you don't even know it. They're just buildings.
Data Center Alley, they call it.
Yeah, that's right, man. It's very cool, without a doubt. So here's what's taking place in the market. It's going to continue to increase. It's going to continue to put the demands on the grid. It might be it might be in Reston, and they're going to have to figure out how to make sure that their grid is stable and clean and running well. What are some of the pushbacks? What are some of the saying? Nah, I don't need to. I can't see anything. I can only see that these data centers, these solutions, they must be hand in hand.
Yeah. The way I see it is we really need to get all the right stakeholders aligned. We have the utility partners, we have technology providers like ourselves, data center owners, regulators, and we all need to come to an agreement that the problem needs to be solved, because it is a bit of something I think is sort of falling back on the utilities, but they've also never dealt with gigawatt scale customers that have a fluctuating load, right? So we're in a little bit of a who needs to solve the problem, who's going to pay for the problem. We can't put it all back on the ratepayers who just want to power their toasters, right? So there's a lot of, and Sergey is involved in a lot of committees, a lot of technical committees, and a lot of conferences ongoing right now, because we're getting closer and closer to gigawatt scale AI data centers wanting to be connected. And it's kind of that tsunami wave we see coming at us, and we have solutions. I think admittedly, there's a lot of different solutions out there. They're all, they all have their positives and negatives, right? And I think we think ours is a good one, and so do some other similar companies to ourselves. But we really just need to get in the room and agree on how we're going to move it forward and start putting some things on the ground, because, like I said, they're going to be connecting soon.
Yeah, it's happening. It is. It's going to happen. But you brought up, you sort of skirted on it, it's the rate case. It's the rate payer. It's in there. Who's paying for this? And you know as well as I do, I don't want to pay more.
Yeah.
I want to be able to sort of go online and do my AI stuff and whatever it might be, but I don't want to pay. Those are all really significant challenges, and it goes beyond. That's a whole nother conversation to be able to figure that out. And honestly, it's way above my pay grade.
Yeah. And I often like to say that we don't give ourselves enough credit in our industry for the fact that we provide probably the most economical product in the world. Is we sell electricity to millions and millions of people for a couple $100 a month, right?
Yeah.
And it's and with 99.999% reliability, right? And we have to maintain that while we deal with all these challenges that we talked about today. So
exactly, it's an exciting time. It's really frothy of just insights, and it's just really meaty, because I again, my view was very linear, and now all of a sudden, how do you manage these sources of generation? How does it impact? like electric cars. Okay. They're plugged in. I don't know how a system operator deals with that. I don't.
Yeah. Well, that was the one before AI, and now it's not even talked about. Right?
Yeah. Very good. Sergey, as we wrap this up, how does people say, man, I want to know more about what's happening at STATCOM, E-STATCOM, what's happening at Siemens Energy? How do they get a hold of you? What's the best way to do that?
You can find my name in LinkedIn. I'm the only Sergey Kynev over there. Or you can contact Siemens Energy. If you are electrical engineer, come to IEEE conference. Will be the one in Austin in a few weeks. We're gonna be there. There is a lot of different task forces and standard development groups which were involved. Just contact Siemens Energy and we will have a very interesting discussions.
Oh, LinkedIn. All right, Matt, best way to get a hold of you.
Yeah, same. If you go to the Siemens Energy website, you can find us through our Grid Solutions group, again, based here in Raleigh, North Carolina, or you can LinkedIn as well. But yeah, we're if anybody has any challenges to what we said today, we'd love to hear them.
Because it's all about collaborating. It's all about getting the right people in the room, discussing these challenges. It's the only way to happen. You guys were absolutely spectacular. Thank you. Thank you for finding time. This was a great conversation. All right, listeners, we're going to wrap it up on the other side. We're going to have all the contact information for Sergey and Matt out on Industrial Talk, so fear not. Reach out. Put them. These are must-connect individuals, so stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Yeah. Did I tell you that we just sort of scratched the surface of what they can do? There's so much going on out there that if you're not committed to trying to continue to educate, continue to reach out these individuals, have these conversations, you're going to be left behind. I guarantee you, you're not seeing the full picture. You have companies like Siemens Energy and individuals like Matt and Sergey who make it their business, make it their profession to be able to look into what's happening to solve your problem. Right there, LinkedIn, reach out, make it a point. Again, I touched upon it. Industrial News Network, industrialnews.network. That's the URL. We're changing the game. We want you to participate. You need to succeed. This is the platform that lets you succeed. Be bold, be brave, dare greatly. Hang out with these two gents. You're going to change the world. We're going to have another great conversation shortly, so stay tuned.